Okay, hi you guys. Welcome back as I find my notes. Okay, what if the remainder is not 0? Because it will not always be 0. Then you need to write your answer in this form where q of x is a function in terms of x. It's the quotient. It's what you get. Like, okay, this would have been called the quotient for number 2. Sorry. Oh, right. I don't have the answers here. This answer that we got for number 2, that would be called the quotient. So what you get on top is called the quotient. But what happens here is when you have a remainder, which would be your r, or sometimes r of x, it could be a function, it could just be a value. For us in Algebra 2, it's just a value, over the divisor. The divisor is here, the denominator, what you are dividing by. So we're going to follow our same steps to do this problem number 4. What you get after you divide is just written as a regular polynomial. What you get as your remainder, you have to add that remainder over the divisor, over what you originally divided by. It's just you're going to just do it. We're going to do it. Okay, so Q is for quotient, R is for remainder, D is for the divisor, what you're dividing by. Mine, when I printed it, because I printed this at home, it didn't have the plus 78, so I'm not sure if yours did or not. So make sure you check that on your paper. So we start, remember, by writing the numerator on the inside, and the denominator is what you're dividing by. That goes on the outside. 6a to the 4th, you start with the first term, divided by 2a, the first term on the outside, is 3a to the 3rd, okay? So now you take that 3a to the 3rd and you multiply again. We just divided to get it, so you remultiply. You know you're going to end up with that same 6a to the 4th. But don't forget to distribute to the -3 also, or the -3, they're the same, to get minus 9a to the 3rd. Now, don't forget that you need to do the opposite. So in this case, you would subtract the 6a to the 4th, but because there's already a minus sign in front of the 9a to the 3rd, you would change it to a plus. Minus a minus changes to a plus. Holy crap, I don't know what I'm doing. Okay, so we bring it down. We cancel the 6a to the 4ths, and negative 5a to the 3rd plus 9a to the 3rd is 4a to the 3rd. Bring down the 18a squared and the minus 4a and the plus 78. So now you look at this first term, 4a to the 3rd. And again, divide by the 2a in front. 4a to the 3rd divided by 2a is 2a squared, right? So you remultiply, you know you're going to get 4a to the 3rd. We already know it. What you still need to do is 2a squared times the -3. That is -6a squared. Change both of the signs. Subtract the 4a to the 3rd. You're subtracting a 6a squared that's already being subtracted, and minus a minus changes to plus. So you change both of the signs. Those cancel. And that adds now to 24a squared. Bring down the minus 4a, bring down the plus 78. Your new first term, 24a squared, gets divided by the first term, 2a. 24 divided by 2 is 12. A squared divided by a is a. A squared here divided by the a here is an a left over. So multiply and you re-get the 24a squared that we already got, and distribute to the -3 to get -36a. You need to subtract. So you're subtracting the 24a squared and you're subtracting a 36a that's already being subtracted. Minus a minus makes a plus, which 36a minus 4a is 32a. Bring down the 78. And as you can see, I kind of run out of room. 32a, our new first term, divided by 2a. 32 divided by 2 is 16, and the a's cancel. So 16 times 2a is 32a, and 16 also gets multiplied to this minus 3, which is minus 48. Subtract, change the signs, and that adds, I might have done this wrong. I did. It's okay. I'm going to have to change this to, okay, that's 126. I think we're going to go with it. I'm pretty sure that's 126. And which means that is called, there's nothing else to do here. This 126 that has no variable cannot be divided by 2a. If there's no a with the 126, then it can't be divided by 2a. Okay, so when you get down to it and there is a number left over, if that number is not 0, it's called your remainder. So we have to remember what we wrote or have written on our notes already. Your answer is the quotient right here up at the top. Your quotient plus the fraction, your remainder over your divisor. I know this is a mess. It's okay. It's really not that bad. It's no different than what we did. It's just now you have your quotient plus your remainder over your divisor. Okay? And this is almost as guaranteed to be on the Regents as it's one of the most guaranteed questions you'll see on the Regents. I'll have to go check if there's ever a year that it's not on there. So quotient plus your remainder over your divisor. Okay? And from the Regents questions that I've seen, most of them, they give you this or some form of this. So that should be a hint to you. How do you know what to do? If it shows you this is your type of answer, you should always think of, okay, I get those answers from polynomial long division. So determine the quotient, that's a key, the keyword quotient, and remainder, you get remainders from long division. When this polynomial is divided by this other polynomial, so it's polynomial long division, and it's giving you the form that it needs to be written in. This one is so much easier. So we start with the numerator in this case. This is being divided and is being divided by, what's being divided by goes on the outside, right? Okay, x squared divided by x is x. Distribute, you get your x squared, which we know x times 1 is x, or 1x, okay? Subtract, so it had a plus sign, so we get to change it to a minus. Those cancel. 3x minus 1x is 2x. Bring down the 6. 2x now gets divided by x. 2x divided by x is 2. Distribute, you get back to your 2x. Distribute, you get 2. 2 times 1 is 2. Subtract, your remainder is 4. 4 cannot be divided by x, so it just stays your remainder, okay, your r of x. Now, it's not in terms of x, but it can be, okay? There are other problems where your remainder is still a polynomial, just not for our examples. So our answer, because it has to be written in this form, the quotient comes first. The quotient is what you get after you divide, the x plus 2. What do you do when there's a remainder? You add that remainder as your numerator with the divisor, what you divided by, x plus 1 as the denominator. Okay? If you did good on the last video, then this should be nothing for you. If you needed more examples, then hopefully this provides some more. If you still need more, you have to reach out and let me know. Oh yeah, we haven't done one like this yet. Remember your polynomial, so I only said this once quickly on the first notes. Your polynomial must include all terms less than the degree. What I mean by that, this goes 6a to the 4th, 5a to the 3rd, 3 comes right after 4, 18a squared, okay, it goes, see how it goes, the exponents, 4, 3, 2. A is technically a to the 1st, and then the 78, the fact that it has no a's, that would be like a to the 0, right? So it goes in order, a to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0, okay? It needs to have all terms less than the degree. So this one is 16x squared. What would have to come after x squared? X, or x to the 1st. And then after x to the 1st would be your number without a variable at all. So to make it work, you have to use a coefficient of 0. Let me show you what that looks like. You start with your 16x to the second. That's what you start with. You need to have an x term after it. So because it's not here, you add it in with a coefficient of 0. Okay, because 0 x's, it's still the exact same. You still have 0 x's. It's a placeholder. You need to hold the place of an x term, and you'll see why in a second. 16x squared divided by 2x is 8x. Okay, multiply and you get right back to your 16x squared. What is 8x times 1? 8x. You cannot put 8x with 3. They're not like terms. So to avoid making that mistake, that's why you need to put this placeholder here so that you have a common term to go with the 8x that you get by following the steps of long division. So you need that 0 coefficient as a placeholder because these are not like terms. You cannot line them up. Like terms must be lined up. So subtract, whatever, and you get negative 8x, bring down the minus 3. Negative 8x divided by 2x is negative 4. Multiply, you get negative 8x. Multiply again, the negative 4 times a positive 1 is negative 4 or minus 4. It doesn't really matter. Okay, we're subtracting something that's already negative, so that's going to change to addition. We're subtracting something that's already negative. It's going to change to addition. Those cancel. You're left with 1 as your remainder. When you have a remainder, that means you have a fraction, right? It's the quotient that you got plus the fraction, remainder on top, divisor, denominator. D divisor, D denominator. Okay? So that would be 8x minus 4 plus 1 over 2x plus 1. All right. Number 7. This was a Regents question. So what, what you should always do, what I always do when I'm looking at the Regents questions, see if this is factorable, because if you can, and actually that's next unit, but just as foreshadowing, if this is factorable, sometimes you can factor and simplify it that way, but this is definitely not factorable. This is x to the third, that's x, there's no x here, there's nothing in common, it is not factorable. If it's not factorable but written as a polynomial fraction, you do polynomial long division. A polynomial fraction means polynomial long division. So we set it up, we divide 4x to the third by 2x and you get 2x squared, and then you distribute, right? We needed, again, our placeholder here. That's why I put this question here, because if you just see the x to the third and you forget that it needs that x squared in the middle, you're going to try to put this negative 2x squared with the 9x, and they can't go together because they're not like terms, but it still happens a lot. So don't forget to always check x to the third, x to the second, x, nothing. X to the third, x to the second, x, nothing. All right, so now the rest of it is really straightforward. Subtract, change to addition, bring everything down, go away. Not you guys, just the box. You don't go anywhere. Okay, 2x squared divided by 2x is just x. We can already see our answer. We can already see our answer, but I'm going to finish it anyways. Multiply it out, subtract, add. 9x plus x is 10x, which can, oh my gosh, I'm going to run out of time. Okay, 10x, go away, can be divided by 2x, and you get 5, okay? Multiply to get the 10x back, and multiply the 5 times the negative 1 here to get negative 5. And when you go away, subtract and add, everything cancels. So we get that remainder that we like, 0. That's why it's a happy smiley face, 0, because we like that remainder the best. So this, with no fraction, is your final answer. So that clearly goes with number 1. Hopefully I don't run out of time before I get to show you this. It just happened that none of the examples that I picked had it. It usually always does, but you can end up with a negative number as your remainder. So you have two different options of writing it.